So disconnect and join, okay? Anybody not able to see the screen, disconnect and join. If that doesn't work, take a car, take a Uber, come to the classroom. Okay? I know Manas has been struggling with this issue of late. That's why Manas stays pretty close. He can come to the classroom. Not applicable for many other kids like Dikshita or Sandens Lane. Okay? So, can you see me now? Manas? Srihan. Yeah. Disconnect and join, beta. There is no other way out. There is some problem at your end. Everybody else can see me. You'll have to talk to mommy, daddy. Start coming to the classroom. Or buy a new laptop. Something of that sort. Yes, Srihan Sagu. Yeah, tell me, beta.
No, I just left because
Yeah. Do you want to tell your name? How do I pronounce your name?
It says Srihan Segu, but my real name is Siddhan.
Siddhan? Okay. Okay, so Siddhan. So welcome to the class. Just a quick update for you. This class is meant for learning concepts. We don't learn math to get stressed out. Our goal is to learn the concepts in an easier way so that we can relate to it and practice as much problem we can. So during the class, my request would be don't worry about taking notes. Okay, don't have to worry about taking notes. Everything that we are doing, not you guys, but me, I and board is getting recorded, and you'll have a video of the class which you can watch later to do a recap of what we learned. Okay, so don't worry about taking notes. Your focus should be on understanding and following the concepts, and then see the application of it. Okay, so fight with me, argue with me, debate with me on any concept that is not clear to you, but don't worry about taking notes. Okay, so let's get started. So in the classroom we have Adri Karav, Aryahi and Urvi. So let's start. What, if you guys recall what we were doing in the last class, obviously Siddhan will not know. Siddhan, right? S-I-D-H-A-N?
Yeah.
Okay.
It's Siddhan, but you can call me Sidhu.
Sidhu, okay. So Sidhu would not know what we did in the last class. But for the kids who were there with me before, do you guys remember what did we do in the last class? Sandin, Celine, can you tell me, beta? Or Milana? Yeah, Milana, go ahead.
Surface area?
Surface area and volume of simple objects. And what are the simple objects?
We use the water bottle for example.
No, nobody will. Everybody is independent here. Okay, let her say whatever she has to say. Nobody will keep poking, keep looking at her, say what is going on. Not like that. Okay, let her do that. Yeah, yes, beta, go ahead.
We were doing. I don't know how to explain it.
Okay, let's see what will we remember. Yeah, it's okay, beta. It's fine.
It was like shapes and like. No, I don't know.
Okay, Abhi, do you remember what did you do in the last class? Yeah.
3D objects.
And what is that?
3D objects.
3D. All volume and surface area. When we talk about, we talk about 3D objects only.
We talked about cylinders.
Right cylinders.
Oh.
And
The surface area of it.
Lux, do you remember what did we do in the last class?
No.
No? Sandy and Celine, tell me, beta. Sorry, somebody has to tell.
Volume of a cylinder and find the surface area of that?
Yes. Sorry, yeah, go ahead.
I was going to say the same thing.
So, okay, and do we have Vasundhara, Arihan as well? Do you guys remember what did we do in the last class? So, okay, let me not make Sidhu concerned about why we are taking so much time to figure out what we did in the last class. I thought it's only me who is old, who doesn't remember things, but you guys are also forgetting things. There are 3 shapes, 3 objects that we learned about. 3 after the class. All the discussion has to happen after the class. Is this your pen? No problem. Leave that pen aside. It's okay. Here, we talked about 3 primary 3D objects. Cuboid, cube and cylinder. And we learned about how to find out the volume and surface area of these three objects. A cuboid, a cube, and a right cylinder. Yeah? Gayatri, do you remember better? Or I'm convincing myself? You were not there in the class yesterday? Okay. Hiranya, do you remember better? No? Okay. So, all of you are forgetting it. That gives me an opportunity to not teach you anything new and do a repeat of what we did yesterday. We have somebody named AMR Synergy. Who is it? AMR
I'm talking from my machine. Sorry, it's Manas.
It's Manas. Oh, okay. That's why I was wondering how come I don't know some of the kids. Okay.
Yeah.
Okay.
Just for today, I've allowed him from this machine so that.
No worries. No, that's fine. As long as I know who the child is, that's fine. So that I address the kids. Okay. So, everybody here, I see some kids are still missing. Arihan, do you remember what did we learn in the last class? We talked about three main objects. A cube, cuboid, and a right cylinder. Yeah? A cube, cuboid, and a right cylinder. What is a cube? What is a cuboid first of all? You have a rectangle. No, hands up. Now I will go with my flow. Don't raise your hand unless you have been asked to raise your hand. What is a cuboid? You take a rectangle and add height to it. Meaning you had a piece of paper as a rectangle and you added more and more pages to it. And it got height. Yeah? If I add 500 more pages to it, it will become thicker and taller. I add 50,000 pages to it, it becomes even taller. Yeah? So, that is what is a cuboid. A rectangle, when you stack one after another, so many rectangles of the same size, that adds height to it, and that is called a cuboid. Now you imagine, you took a square. What is a square? Length and width are the same. All four sides same. You put square after square after square after square after square, and you are adding height to it. Till the time. So here, in case of cuboid, what happened? You had a rectangle, length and width. In case of a square, you had length and width, both were same. So this is length, this side is length, this side is length. And you added height to it, and the height is also same as length. That is what is a cube. If you're talking about an ice cube, everybody is familiar with. It's a shape of ice which has length, width and height same as 1 centimeter. That's why it's called one ice cube of 1 centimeter. Okay. So a cube is a 3D object which has length, width and height all same. A cuboid is nothing but extension of a rectangle. If you're talking about a right cylinder, it is nothing but extension of a circle. If you keep the circles after circle after circle, so many circles one after another, if you guys have seen your ladies in the house wearing those bangles, so many bangles put together, those are all individual circles. When you put them together, it gets the shape of a cylinder. So imagine this water bottle being made of so many of those bangles, monster bangles put together, gets a height to it, and that is what is called a cylinder. Is everybody okay so far? Okay? Alright. Sandin, Celine, Gayatri, Manas, Sanvita, everybody okay? Sorry, okay? Okay? One question is still not answered. Who is Sanvi Kuni Reddy? Is that Suhina or is that Sami? or somebody else whom I'm not able to recognize? Oh, that is.
I was Srivatsani said
Oh,
today.
okay. So, Sanvi Kuniredi, if you turn your video on, my question will be diluted. I recognize all my kids by face. Sometimes
I'm
make.
trying to find the reaction button on my computer. Put a thumbs up.
No, that's okay. I'm saying just turn your video on, so that way I can see the child and I would know which child I'm talking to.
Okay. 1 sec.
Yeah, sure. So, we saw three main objects, the three-dimensional object, meaning which has length, width and height. If you're talking about rectangle, extend it, that's a cuboid. If you're talking about a square and extend it such that height is also matching with the side, that is a cube. And if you take a circle and extend it to get a height for it, Sanvi is the Sanvi who is my student. So that's why I was wondering, is this the same Sanvi or some other Sanvi whom I'm confused about? Okay, it's okay with that, that's fine. So this is right cylinder. Now, what do we mean by volume and surface area of any shape? Volume is no question asked. Volume of anything is nothing but the space it takes. My volume is the space I need in this classroom. Imagine me being bulky enough, looking like Mr. Hulk. I might not be able to fit in this classroom because I need more. My volume is more than the volume this classroom has. Yeah. If I become like an elephant, then for me to be able to teach, I'll not be able to fit in this classroom. You would need a much bigger classroom, monstrous classroom. So volume is nothing but the space anything takes, and there's a way to find it out. Volume, see, this thing is needing more volume when I have more and more pages, meaning more the height, more the volume. Now, so whatever is your area, you are adding height to it. So take the base area, multiply that by height, that gives you the volume. If you look at this guy, this is your length, this is your width, and this is height. What is the volume of this? You are saying that find out the area of the base. Area of the base is nothing but like a rectangle. Length into width, multiply that with height, that is the volume. If you look at the cube, what is the area of the base? Volume will be area of the base, which is, this is a square. Area of a square is what? Side into side. And then multiply that with the height, which is again same as the side. This is the volume of this one. If you're talking about this guy, again, you'll find out the area of the base. So area of the base will be, it's a circle, it will be pi r square. And if this is this tall, this is the height. Multiply pi r square by height. That is your volume. Yep. So any symmetric shape, any symmetric 3D object, the volume of that will be area of the base times the height. Area of the base times the height. Area of the base times the height. This is the volume. Yeah? Everybody okay? Vasundhara okay? Tasvik okay? Saurya okay? Saurya, why don't you turn on your video, beta? I've not seen you before. Maybe I have seen you before, but I don't remember having seen you more often. So when kids are ready, I would just suggest or request you guys to keep your videos on. So that way.
Give me 1 sec.
Sure. So this is the volume part of it. Let me not worry about the surface area for now, because more we talk about surface area, you guys will start getting confused. Now, in the class today, we wanted to learn about 2 more 3-dimensional objects. And what is that? Yeah, those are cones and spheres. Will fire come out of it? Okay. We are going to learn about 2 more 3D objects. One is called cone and one is called sphere. Now everybody, who all plays soccer in the school?
He will.
Without knowing the question, he has raised hand. Okay. Everybody who has seen anything round in shape, a ball, a soccer, a football, whatever it is, even the earth is a perfect sphere. So we are talking about a sphere. When we were talking about this guy, we said, okay, area of the base times the height. Now this is a sphere. Where's the base? Where's the height? So don't stress out. Think about it this way. That for now, you guys have to know that, okay, sphere, this is the radius. Everywhere the same radius. So the volume of this guy is 4 by 3 pi r cube. I'm super smart. Now, this is something that I've done forcefully to convince myself. I thought I will try to explain this to you guys, but the unfortunate fact is, hands down. Unfortunate fact is, it is derived, can be derived based on calculus. You guys have not even learned pre-calculus yet.
What's a calculus? Oh, calculus.
Calculus. It's a high school.
Genculi, menculi. That is how you get calculus. Man, don't rush. Enjoy your childhood. When you grow up, you will learn a lot of things. Let's not worry about it. Okay. So what I'm saying is, this formula is derived based on the concepts of calculus that you guys will learn if you stick with me for 4 more years or 3 more years. Let's not worry about it now, because it's 11th, 12th grade thing. Calculus is even college stuff. You can skip calculus till high school. You can choose that in the college. So that's up to you guys. So don't worry about it. When we learn calculus, that is when we'll decode this one. For now, we have just learned this formula which we can use and apply. Okay. So volume of a sphere, again, sphere is a perfect ball, perfect circle in all 3 sides. Whether you look at from this side, that side, up, bottom side, left, right, whatever. Volume of a sphere is 4/3 of a pi r cube. So pi, everybody knows 3.14 or 22/7. Multiply that by r cube, that is your volume of a sphere. Is that okay? Gayatri, San Celine, Manas, Sundara, Harihan. Okay. Nihan, how about you? Okay, everybody okay? So basically, look at what are the 3D objects we talked about. A cuboid, a cube, and a right cylinder. And for these shapes, what we need to know is, if you have to find out the volume, you find out the area of the base. Because, could you stop doing that? Find out the area of the base, multiply that by height, that is your volume. More the height, more the volume. Even if your area remains the same, the base remains the same. For cuboid, you say, okay, my base of the cuboid is a rectangle, length and width, and this is the height. So if I do length times width, that gives me the area of the base, multiply that with the height, that will be my volume. Same way here, for a cube, you said, okay, what is the base? It's a square. And area of a square is length times length. And here the property is the height is also same as the side. So area of this will be, area of the base will be length times length, that is length squared, times height, which is again length. So length cube becomes the volume of a cube. In the right cylinder we saw, what is the area of the base? Pi r square, because it's a circle. And then multiply that with the height, you got the volume of a right cylinder. Then we go to a sphere. This is where I'm forcing you guys to memorize the formula for next 2.5 years. When you guys grow a little bit older, not as old as me, little older, hands down. No, I'm not entertaining in discussion right now. Then I will explain how this formula is derived, but for now, this is a formula. I'm not trying to rush to explain this to you, because if I start talking about calculus, everybody will be confused, including me. Because before I teach you guys, I have to prepare this in an easier way. So we are not talking about that. We will use this formula for now. Is that okay, Urvi? Yeah? Okay? Yeah. Now, there is one more shape. Who all does work at home? Helping mommy or parents? Who all? Let's say if somebody...
Wait, what was the question again?
I was asking who all helps the parents at home? Okay?
Sir, you're on mute.
My question was, who all helps the parents at home? I can see 3 hands being raised.
I do.
Okay, everybody does. A lot of kids do. Okay, Dixit also does. Sami also does. Now, okay, sorry also, everybody does, right? Now, a question to you all is, which equipment would you use? I will not let you answer it. I will not let you also answer it. The question is not asked, people are ready to raise the hand. Let you also raise it down, put your hands down. My question to you all is, which equipment would you use if you have to pour oil in a bottle which has narrow... I will not let you answer, you both.
I did this last week though.
You did?
Yeah, actually I did. Remember the thing?
You are weird.
Hands down,
Remember the
everybody.
thing?
So, okay, what?
A funnel.
A
Yes.
funnel, okay. Okay, so Subbu, right? Or no, I'm missing a name again. For the new child, I forgot your name, beta. Sidhu. Yeah, now I'm getting it. Sidhu, what equipment do you use for pouring oil into a bottle which has a narrow, head?
Passage.
Passage. Okay, whatever. Yeah.
What's a passage?
The cone thing.
Cone. A cone thing. It's a cone. It's called a cone. That's the mathematical term for it. So a funnel is something that looks like
D.
this.
What is this? A birthday Oh.
No time for unnecessary stuff. If you're getting tempted to talk unnecessary stuff, please do it with my neighbor next door. He loves that. So here, this is called a funnel or a cone. So far, we talked about area of a right cylinder. It has some relevance with this guy. Look at it. If I cut this, okay, if I drill a hole in this one in such a way that it is a tapered one at the bottom, this can be made out of a right cylinder, and this is called a cone. So if I look at this cone, it has one. If I look at a perfect cone, and let me flip it upside down. If I look at a cone like this,
Not funny, bro. It's not funny.
no,
It's not funny. Oh, I'm bad.
there'll be a day when I'll call one number. There'll be a day. It could be a late night discussion also, when I can call a number, and that'll be best day of my life. Might not be as great for many of the kids, some of the kids. So here is the funnel, which I have put as upside down. If you look at it carefully, you have a circle at the bottom and a point at the top. Yeah? Sidhu, does it make sense?
Yes.
If I expand my visualization a little bit more, it makes me believe it would have been a right cylinder, but we tapered it from two sides. So my right cylinder, if let's say this was the radius of the bottom of the cone, if this was not tapered like this, the volume of this would have been, this is h, so area of the base pi r square times h. If this was not tapered like this, but what you see is this is split into three pieces. One piece here, one piece here. Okay? And this side also, if you think of a three-dimensional view of it, this side will make another cone, this side will make another cone. So basically, this right cylinder can be split into three cones, and volume of one of the cone will be 1/3 of the volume of a right cylinder otherwise.
Instead
So
of everything, just 1/3.
1/3 of pi r square h. Don't ask question for the sake of asking.
I was gonna ask, could we also derive like a pyramid has like a base of like times width, but what are we still?
Kill the argument. Kill the argument. Learn, then we'll talk.
Okay.
Debate has to start after learning. It cannot start at the beginning of the learning. Okay? Learn this concept, practice few problems, solve it accurately, then we'll debate. That will make more sense. Right now, we are doing some airy discussion.
Yes, sir.
Airy discussions don't impress me.
Yes, sir.
Okay? So, basically, summary of this is, if I'm talking about a cone, the volume of a cone is 1/3 of what would have been the volume of the right cylinder with the same base and same height. 1/3 of pi r square h. Does it make sense to everybody, or
Yes, sir.
Gayatri, Laksh, Sidhu,
It's
Sandra?
making sense, but it's getting complicated at the same time, you know, because it's like at another level.
See, life keeps on getting complicated. I had a lot of hair, luscious hair like you when I was your age. See, I kept on losing it due to stress that comes with math. No, I'm just kidding with it, okay? What I'm saying is, there'll be interesting concepts that will come across. And all the things that we learn for the first time, that will look difficult. What is the way to make it easy? It's like knowing about ghosts. You learn about ghosts, oh, ghosts are scary. When you start seeing it every day, that fear is gone. So math, any concept is a ghost. You'll be scared of it if you don't practice problems. If you practice problems, that ghost disappears. It'll be fun. Yes, Tasvik. Yes, please.
What if we're not scared of ghosts?
I have Satnam Prabhu Puja after 2 months at my house. We'll talk about it. Okay? So somebody is wanting to talk about why I'm not scared of ghosts. Because I solve problems, that ghost is gone. We'll do puja, some worship at home, that will take care of the fear that we have otherwise. So there are two things, two objects that we learned about today. Two three-dimensional objects. One is a cone and one is a sphere. The sphere, I'm trying my best to make you guys believe that this is a sphere. Look at it carefully. This is the dotted background which says that there's something in the back. Basically, it's a ball or a sphere or a round thing which resembles with the earth, a globe. Speechless. I'm speechless right now. Okay, but I hope you guys are not speechless. This is making sense to you guys. And the volume of the sphere is 4/3 of pi r cube. These two formulas you are kind of being forced to memorize. Hands down. I'm not going to entertain a discussion right now. These two formulas you will memorize for now, but we'll look at the application of it first. And when you guys grow up a little bit, we'll leverage calculus for deriving these formulas. So if I'm not trying to derive it now, I mean, for kids like Sidhu who's attending the class for the first time, you must be thinking, what is the need for deriving the formula? We do it because any formula and every formula that we come across, I try to break it down so that you understand it and appreciate. In future, you might forget the formula, but you not forget the concept. If you get stuck somewhere, you can derive it by yourself. That's the reason for proving the formula, deriving the formula. Because Because learning something with a concept stays longer with us. But just memorizing it is little dangerous, okay? You might think that, okay, I'll memorize 20 formulas and I'll get 100%. Might be a good idea, as long as you memorize everything and you know application of it. But if you are clear about the concept part, it's easy. So I'm still holding it with me for now. I can only use calculus for proving this, so I'm not doing it right now. But conceptually I said, visualize this line. It's a right cylinder and you have split into 3 equal parts. That's why the volume of this is 1/3 of what would have been the volume of a cylinder. Hands up. Okay? Any questions with respect to this? Tell.
So, if we had a cone cylinder, could we like unfold it to make like a rectangle? Like
No,
that?
no. No, do it at home. Try making a cone. No, I'm just not kidding. Try making a cone. Make sure that your extra paper you have on the side, you take it out. And then try unfolding it. If it turns out to be a rectangle, I would love to see that. It doesn't do that. It doesn't do that.
Oh, okay.
When you unfold a cone, it will become something like this. It will become something like this. Okay? Not like a triangle. It will be something like this. I'm just trying to visualize. And something like this.
Have you ever tried it?
To make a parallelogram. What is it? That?
Ice cream. Eat it after you unfold it. So what I'm saying is it will not be rectangle for sure. Okay?
Oh.
Let's not
I can
worry
see
about
it.
it.
I can see it.
Yeah. Okay?
Just fold it.
So let's look at some problems that I have created for you guys. I wanted to create problems for you guys. I wanted you guys to try solving some and see if the concept that we have seen or the formula that we have learned or come across, is it good enough for us to apply it somewhere? Let's see.
Yes, sir.
Okay, stop talking about unnecessary stuff. Doesn't help. So now, is everybody in the class with me so far? I am making some kids sleep or fall asleep.
Yes, sir. You are very good.
Sandin, Celine, Sarya, Sanvi, Tasfix, Sami, Abhi, Asundara, everybody okay, right? Sidhu okay? Let's try solving some problem. Okay, invest your energy for doing some problem. We have been asked to find out volume of the sphere.
Yes, sir.
We have to find out the volume of this sphere that you see on the board.
Actually, it looks like Brazil. But
Okay, can you stop blabbering?
Okay. I'm not lying. Actually, look.
Araf,
I'm at.
Araf. Nine centimeter. This is given as 9 centimeter. We have been asked to find out the volume of this sphere.
Yes, sir.
Do it first. I'm not in a hurry to see how quick you are with the response. I'm here interested in.
Formula?
Why would I give you a formula? What was I doing before?
Oh, I'm like, so for
Should we use 22/7 or 2.4?
Use some. I don't know. Outside the class.
No, that's a genuine question.
Not a question for me at all. You know 3.14, you know 22%, that is your choice. You complete something, then you talk about it. You guys are ready to talk without doing something. That's where the problem is. We have a sphere with the radius of 9 centimeter. I'm asking you guys to find out the volume of this guy.
Yes, sir.
Stop saying sir, every 30 seconds. Sami, Sanin, Celine, sorry, are you guys able to do it? Sanvita?
We're still working it out.
Okay. But you guys are clear about what to do, right?
No, I need help. Can you explain it afterwards?
Sure, I will.
Thank
Abhi? God has given you a notebook and a pen. Use that. Vasundhara, are you able to try it better? Okay. How about Sidhu? I will try it.
Wait, we're finding surface area, right?
No, volume, no surface area.
There you did it again.
Volume, no surface area. I did not talk about surface area at all.
Oh, okay.
Sandin, go ahead with that.
I don't think this is correct, but I got 3,052.08.
Why are we talking even then?
52, okay.
No, so again, on a serious note, okay? I want you guys to be more confident than me.
Can you please tell them?
Whatever.
Because I think I forgot.
Anup, please. Stop that. I'll come to it. So Sandin Lane, and everybody here in the class, I want you guys to be more confident than me. Whatever you did, you will say it with confidence, okay, my answer is this. Right or wrong, we'll figure it out. Don't worry about it. Okay? Please promise me that everybody in the class, whatever you tell me, you will tell that this is my answer, no matter what. We'll figure it out. Yes, Sanvita, go ahead.
I got 3,052.08.
What? 300,050 centimeter cube. Yeah, I was interested in that. Yep. Okay. I'm not saying whether that is correct or not. We'll figure it out. Yes.
I got approximately 3,054.85 centimeters cubed.
This is a matter of research. What would be better? Are you able to try it?
I'm trying, but I don't think I'm doing it right.
Okay. No, do it. So again, I don't like that statement. I don't think I'm doing it right. It's okay. Whatever you do is what you know. If there's something that we're missing, we'll fix it, better. It's okay. How about you, better? Okay.
I got it. 3,000. Oh,
Yeah.
I got 3,052 point.
That is not you got. You're borrowing from him.
And it's not 52, it's 54.
Okay, guys, everybody here. Everybody here.
Yes, sir.
Everybody here. Come here. Okay. So pay attention to what we're doing. There's one formula that I kind of forced you guys to believe, that if I have a sphere, then volume of the sphere is 4 by 3, like you guys have memorized 6, 7, 4, 3, 4 by 3 pi r cube. 4 by 3 pi r cube. 4 by 3 pi r cube. Now let's put the numbers, that's it. 4 by 3. Okay, Arab, I did not give you a chance to continue the discussion.
Yes, sir.
22 over 7 is my pi. R cube. R cube is nothing but the radius cube. My radius is 9 centimeters. So 9 centimeter cube. 9 into 9 into 9 is what will be 9 cubes. Okay, so let's see how much it is.
200 and what?
279 probably.
I got it.
Take it. You got it, take it. Take it home. Okay, here. 9 times 9 is 81 times 9. 9 1 is 9, 9 8 is 72, 729. So it becomes 4 by 3. Shh. 4 by 3 is 1.33 into 22 by 7 is 3.14 and then into 9 cube is 729. So 1.33 into 3.14, it will be somewhere around 4, okay? 4 into 729. Close to 3000 is what I'm hoping. But that number is not important. What did we do? Nothing. We just got the radius and whatever I had forced you guys to believe, we plugged in the value of our radius there. That was it. And then rest was calculation. Yes, Sanvi.
What's so
You
funny?
don't want to make me sneeze.
Oh, my bad. It's not funny.
Use you like sunscreen.
Advik and I will not sit together next time onwards. I'm not interested in talking about that.
I have answered before.
How much that is better?
I put my answer as 3,000.
Approximately, yeah. 729 multiplied by approximately 4 will get you somewhere close to 3,000. Yes.
Okay.
Yeah. Tasvik, Arihan, did you guys get it or you had a different answer?
Wait, what's the answer again?
Approximately 3,000 cubic centimeter or centimeter cube.
Approximately 3,000. Right?
Yeah. Sidhu, how about you, beta? What did you get?
I'm solving it.
Still solving it. But you got the idea, right? I mean, nothing new. Yeah.
How would we write out the answer?
I'm
How would
sorry.
you write it out? Because you have to like write.
So, see, when you calculate all these things, you'll get something. So, let's say somebody got 3,000. And then you have 9 centimeters. So, 9 into 9 to 9 gave you 729. Then you have centimeter into centimeter, centimeter also when you take it out. So, centimeter into centimeter into centimeter. It's like 3 into 3 into 3 gives you 3 to the power 3. X into X into X gives you X to the power 3. Centimeter to centimeter to centimeter gives you centimeter to the power 3, which is called centimeter cube. So,
Oh, okay.
I'm learning dance steps. I'll start dancing when you make this kind of a joke, okay? Yeah, Urvi, are you clear, beta?
Yeah.
Okay, alright. See, this is fun to be in the classroom, right? You get to interact with those lively jokes. Okay, alright. So, all the kids who are not in the classroom, you are missing the fun. Some kids are having live experience of cracking jokes and seeing the repercussion of it also. Alright, I'm just kidding. Let's come back to this one. So, this part is okay. Let's pick one more up. This time, I will assume that you guys will be better off.
Wait, so basically. So
No, basically, no, actually, no, scientifically, no, technically. Hear my question first.
Yes, sir. Oh, it's not funny, bro. Is it? Oh my god. I turned this book up into a comedian.
Okay, guys, hear my question carefully.
Yes, sir. It's not funny. It's not funny.
You do.
Find the volume of the sphere. Use 3.14 as pi. So you are told that use 3.14 as pi. So pi equals 3.14. And round your final answer to the nearest hundredth. So you have to get your answer in something 0.00 or something point something up to 100th place. Yeah. What is that?
I have to go.
So this is the radius given as 8 centimeters. Yeah. Sure. So this is the sphere where the radius is given as 8 centimeter. Careful. You have to find out the volume of the sphere, and we are told that we can take pi equals 3.14. Nothing new. You have the formula, you have the value of pi given to you, you have the radius given to you. Find it out. It's all about getting your hands dirty. See, I need to use hand wash liquid to clean my hands after the class. So get your hands dirty as well. Yes, Manas.
I'm sorry to ask you, but is this multiplication?
We know volume of a sphere is how much? 4 by 3 pi r cube. Apply it. Yes, Dikshita.
Oh, what? Did we like find the volume?
Mm-hmm.
Okay. Did you write 8 for the board?
8, yeah. Sami, were you clear with my explanation last time? Or got you more confused?
A little more confused.
Little more confused? Okay. Okay. This time I'll go a little slow so that I don't disappoint you. One more time. Okay. Tasvik, what's happening? Doing it? Okay. Vasundhara, Abhi. Abhiram has been very quiet. Why so? Yeah, better.
I got approximately 2,048 centimeters squared.
One small thing, you might be going right. Only thing that you probably did not consider was is pi 4 by 3 pi r cube. So r cube is radius into radius. So whatever is the value, then you have centimeter cube also. That will be my first red flag. Okay? Just do it based on that, and we'll see. Yes, last week what did you get?
I haven't got it yet, but never mind.
I don't mind. It's okay. Yes, sorry. Go ahead.
But ask her what's the value of pi.
What is that?
I was just going to ask what's the value of pi.
So don't have to wait for me to tell you the value of pi. You can always calculate based on whatever you want to calculate. You can say I've used value of pi as 22 by 7 or 3.14, or even let's say if you're not sure, you'll say okay, I have considered value of pi equal to 15 and then calculate it. Okay? Sorry.
I got approximately 2,150.4 centimeters cubed.
Centimeters cube. Okay, how about Vasundhara? Vasundhara, go ahead, beta. Sanvi.
I got 2,143.573.
What? After that, centimeters cube. Okay. Now I always focus on the unit because that's very important, right? Otherwise, I can always claim that I'm 5 miles tall, 5.6 miles tall. Imagine how tall I would be. Yes, Sandin, go ahead, beta.
We got 2,143.57 centimeters cubed.
Okay. Dikshita, Arihan.
I got 2,143.57
Okay.
centimeters cubed.
Centimeter cube. Arihan, same.
I got 2,137.31 centimeters cubed.
Okay, Vasundhara.
I got 2,143.573 centimeters cubed.
Okay, how about Sidhu?
Oh, I'm still solving it.
Okay. How about Sanvita?
I got 2,145.06 centimeters.
Okay. All right. So all the kids who are still doing it, who have done it, or who are trying to figure it out, I will use the remaining 10 minutes of the class to do it myself. Yes, Laksh, go ahead.
I got 2,458 centimeters cubed.
Okay. Oh, I see one more student. After Laksh. No, I'm just kidding. Okay. All right, Nihan, go ahead.
I'm on the last multiplication step, but approximately I got 2,000.
Okay. So let's do it. So this one is no brainer again. So everybody here, small students should stay away from this problem. They'll get scared. So here, how close you got, beta? It's okay. Tell me.
I got the same answer.
How much? 2,000?
For 2,048.
Then you're pretty close to it. How about Ariyahi?
I'm almost done.
Almost done? Okay. So now, everybody here, trust me, these are easy ones. Easy ones as in, from a concept point of view, because you have a formula, you can apply the formula. Volume of a sphere is 4/3 pi r cube. 4/3, it is 1.33. Pi is 22 by 7. We are given the value 3.14. Into r cube. R cube is 8 centimeter cube of that. Okay? So 8 cube, 8 into 8 into 8. 8 into 8 is 64 into 8. 8 4 are 32, 3 carry forward, 8 6 are 48 plus 3, 512. So this became 512. So here 1.33 into 3.14 gives you somewhere close to 4. Okay, I'm just rounding it for now. Into 8 into 8 into 8 gives me 512. And then I have a centimeter also inside the bracket, that is centimeter into centimeter into centimeter. That becomes centimeter cube. So 5 into 412 gives me somewhere close to 2048 something. Okay, centimeter cube. What is important is this thing, centimeter cube. Okay, when you are looking at volume, you get in the cube of the unit. If you talk about area, you get in the square of the unit. You're talking about perimeter, you get in the 1 power, centimeter, inches, meter, miles, whatever it is. Yeah. So here this is easy. Okay, it should not bother us. Siddhu, Sami, Shaurya, Dikshita, everybody with me so far? Abhi,
Yes, sir.
Manas. So Sami, did it make it a little clear this time, or I was?
Yeah.
No. So this one is simple, beta. Okay. Yes. Go ahead.
Oh, sorry. I meant to say cube, but like I kept saying squared because like I forgot. Like,
Yeah.
I mixed up the two, so I was like, yeah.
Yeah.
I mean squared.
Right. No, so see that's what. See, when you got 2000, I was confident that you are getting there. You are close to the way you are supposed to solve. Sometimes, as a teacher, I keep emphasizing on certain things because you'll come across a situation in the exam where what will happen is, let me tell this. Okay, they will give you 4 options. Okay, they are the volume, they are the 4 options. This is the picture given, and say, okay, find out 2048 centimeter square, 2049 centimeter cube, 4880 centimeter cube, 8000 centimeter square, a centimeter cube, let's say. So here, when you do your rounding, right, you will get there, okay, I'm close to 2048. When you start reading the options, as soon as you get 2048, oh, I got it. But your answer is here. Only the unit thing is the difference. So this is not the right answer, this is the right answer. So that's why, even if I am bothering you guys a little bit more, but the idea is that you should be crystal clear with respect to selection. And let's say somebody gives you this option also, 2048 centimeters. Now, if we don't look at the unit part of it, you'll say 2048, 2048, 2048, which one to pick? As soon as you see the volume, you're talking about 3 dimensions, length, width, height, radius, 8 centimeter, centimeter, centimeter. So centimeter cube is your only pick. These two guys, you will say, I don't care. You'll not even solve this. Don't even look at these two. Before even solving it, when you look at the options, you'll say, okay, centimeter square and centimeter, I'll kill it. I don't need these two. My question is between this and this. And my options are between these two. Yeah. So, you guys still small. I will start teaching you guys about elimination techniques when we start level 3. Right now, you guys will have more time to deal with for solving problems. But when you start getting to competitive mode, where you are dealing with SAT preparation, pre-calculus and those stuff, you will have limited time. You'll have probably 2 hours to solve maximum question that you can solve. And that is where every second that you save by elimination techniques. I will also teach you guys how do you solve a problem, get the right answer without solving it actually. Every exam, you will come across, let's say, 100 problems. Out of 100, there will be 30 problems that you can solve without solving it actually. You just have to catch them quickly. That's all. Yeah? Am I making sense to everybody, or I'm just blabbering and trying to flex my skills? No, I'm not flexing. Right? Arihan, okay with her? Tasvik, Abhi, Siddhu, okay? Siddhu, did I scare you enough in the first class?
No.
No? Okay. Then we are doing okay. Beta, now okay, beta?
Yes.
Okay. So far, we have talked about, I will not solve this problem because we are almost at the end of the class. But there was one more shape or object we talked about, and I want you guys to not to forget about it. That is the funnel that he used for helping family at home. Okay? So, if I tell you that my radius of this funnel, of the bigger circle is 14 centimeters, we have used centimeter enough, let's say this is inches. 14 inches, and the height of this funnel from here to here is 21 inches. Find out the volume of this guy. Do you guys remember the formula for this one? An easy and dirty method for remembering it is, you had a cylinder, you took two pieces out, and what you are left with is 1/3 of the original thing. 1/3 of the original cylinder. Cylinder's volume is base of the area times height. Pi r square times h. Now you have the h known, 21 centimeter, radius is 14 centimeter. Yeah? Milana, making sense, beta? Or no? Yeah?
Yes.
So, with that being said, I think we are good. You guys have already gotten tortured by me enough, right? We don't want to stretch this discussion further. But summary of this is this. We learned about volume of a cone, volume of a sphere, and we had already learned about volume of cuboid, cube, and right cylinder. And every symmetric shape that we talk about, volume, that is area of the base times the height. So cuboid, cube and right cylinder is okay, but cone is not symmetric, right? At the bottom it is wider, at the top it becomes very, very narrow. Similarly, sphere is also not symmetric, right? Because at the bottom it is like a point, at the top it is a point, in the middle it is like a round, big, I'm not using the term belly, but yeah, it's like, Ganesha's big belly in the middle. So anyways, coming back to a serious point. Shapes which are symmetric, like cuboid, cube and right cylinder, you find out the base, area of the base, multiply that by height. And that is how you derive it. We saw it. You guys can watch the video of the class to recollect it, take your own notes. We looked at volume of a cone, which is 1/3 of the volume of a cylinder. That is the formula we learned. We talked about volume of a sphere. We will not talk about this anymore, at least for next few weeks. We'll go to the next unit from the next class. So after the class, I'll upload the video of the class. You guys can watch it and then try doing the assignment. See who has how much of struggle. When I see the assignments, I see you guys are struggling, then we'll probably touch upon this again. Otherwise, we'll take a break from this particular unit for some time, and then we will go to next unit from the next class. Alright? I think enough for today. I'll let you guys go. Alright? Bye-bye. 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 Bye-bye.